All right, welcome 6.4 day one in this video. Sorry, my pen is freaking out here. See if I can get it under control. Um, so we're gonna kind of shift gears. So far we've been doing radicals in this chapter, but we're gonna switch to what's called rational exponents, and the two concepts are obviously related. In fact, we'll learn that the square root of x is actually the same thing as a fraction exponent of 1/2. So if you forget the word rational, rational just means like a over b. So we're going to do rational exponents or fraction exponents. So instead of having just like x squared or x to the fifth, we're going to have x to the like 2/5 or x to the 1/3 power, right? And we're going to do a bunch of different things with these rational or fraction exponents. All right, today is just kind of the start of it, 6.4. All right, so before we get too far into it, I think it'd be good to copy down in your notes these questions and see if you can remember these exponent rules. So like the top two, hopefully you remember how to do, and then today we're going to start to do them with fraction exponents. So take a minute, jot them down, and then you don't have to do this part, sorry. But just have them down in your notes and try them out. So this one's called power of a power, where you just multiply. So we have y to the 15th. And then when it's fractions, it's the same thing. You just multiply them. So you got to remember how to multiply fractions. So 1/4 times 1/3 is 1/12. Multiply the numerators, multiply the denominators. So what's hard about this section is you have to remember exponent rules and you have to remember how to do fractions. All right, next one here, when it is two things multiplied with the same base, you keep the base of x and add the exponents. So here you keep the base of x and you add 1/3 and 2/3 to get 3/3. And then that just reduces to x to the first. All right, as long as you have a common denominator, you can add your fractions. All right, one final thing before we get going is just a quick review of fractions. This will come up in some of the questions, so see if you remember how to add these two fractions. All right, and so the trick is you need a common denominator. And in this case, you can use 6 as the denominator. And so to get these to 6, just take the first one times 3. So 1/2 is the same thing as 3/6. Take the second one times 2. 2/3 is the same thing as 4/6. Now that they're both 6, you can add them together to get 7/6. Right, so you'll need that both exponent rules and fraction knowledge in this lesson. All right, so first thing you want to do is write down this example. This would be radical form. Okay, and then we're going to rewrite it with a rational exponent. All right, so basically this radical is equivalent to having the base of 5 with a fraction exponent of 3/4. Okay, and so when you convert, the trick to help you remember is that the power goes up in the fraction, like power lines up in the sky. All right, and the root or index goes in the denominator like tree roots. So think of power lines and tree roots. The power goes up and the root goes down. Okay, and again, these two things are equal. If you type these two different expressions in your calculator, you get the same value. All right, so the first thing we're going to do is practice converting between the radical form. Sorry, that doesn't look good there, but radical form and rational exponent form. Yes, if you want to make a big chart with radical form on one side, rational exponent form on the other side, and we're just going to practice converting between the two forms. Okay, so if you want to try the first one, you can. You're just going to have x and then a fraction exponent. So if you want to try these first two, you can. Otherwise, you can watch the first one here and then try it. So the power goes up, right? So the power goes up top, and then the root goes down. So think of power lines and tree root. So that this would become x to the 3/4 power. Second one, again, hopefully you've tried these, right, before continuing. So if we have a root of 2, it's invisible, but anytime it's invisible to 2, so the root goes down and the power goes up. So this would be equivalent to a to the 5/2 power. Going the other way, I'm going to write a big radical and an x. So the power line is up, so that's 3, and the root is down, so that's 7. And then the last one, I can't remember why I put this on there. I think it might come up from time to time, but part of this is you have to know 3.5. So like, what is that as an improper fraction? So 3 is 6 halves. So you have 6 halves plus one other half, so that's 7 halves. So once you have it in that form, then hopefully it's a little bit easier. We're going to have a root of 2. The tree root is down and the power line is up. So we have y to the 7th and a square root. And because it's an implied 2, I'm not going to write it there. If you want to write it in there, you can, but generally if it's a square root, they don't write it there. All right, so that's just switching between the two. All right, so just to help us make a little more sense of this, we are saying like the square root of 25, right, would be a power of 1 and a root of 2. So the square root of 25 would be the same thing as 25 to the 1/2 power. So just to help us make some sense of this, right, I'm going to type some of these here on the calculator. So I'm going to do like 25 hat thing, and then parentheses, I'm going to put 1 divided by 2. And just see that that really is the square root of 25. Similarly, 64, the third root of 64 is 4. We're not sure of that, but that should be the same as if we do 64 to the 1/3 power. So I'm going to do 64 hat thing 1 divided by 3, just again to try and make some sense of this. Sorry, my thing freaked out. And it is like the cube root of 64. So 1/3 power is the same thing as a cube root, right? So that's just to help us understand the connection between the two, between the radicals and the rational exponent. Okay, so the rest of this lesson then is just to simplify statements using exponent properties, right? And so here's all the different properties of exponents that we went over a little bit, a few of them at the beginning of this lesson, and they're on page 383 of the book if you need them. And all that's going to be different today is we're going to have fractions in our problems. So it's going to be exponent rules, but just with fractions. And these get pretty wild and pretty hard. So I would copy these examples down and just have them for reference purposes. The hard part is each question is a little bit different, and you really got to know your fractions and your exponent rules. Okay. So luckily, like on this one, it doesn't have x in it at all, so you can actually do it um, with your calculator, right? So maybe if we want to start there, we could just type it in and kind of so we know what the answer should be. So we have 2 raised to the 1/2 power 1 divided by 2. You could also do 0.5 there. That might be a little bit easier. And I'm multiplying with 32 hat thing 1/2 power. All right, and we get 8 by the look of it. All right, so we know that this is going to equal 8, but see if we can use our rules to figure out why. All right, and so at this point, I can't actually, like normally when you're multiplying, you add the exponents, but they have to have the same base in order to do that. So the fact that these two are different bases, we're not able to do that. So one trick that helps on these questions is when you get stuck, switch forms. So we're just talking about 1/2 power is the same thing as square roots. So I'm going to write this as square root of 2 and square root of 32, power of 1, root of 2. Okay, and now that they're both roots, hey, that's what we did early in the chapter. You can smash them together and get root 64, and that is why we get an answer of 8. Okay, so you won't be able to do everything on your calculator like you did on this one. So knowing these rules is going to be really helpful. All right, so this one definitely you're not going to be able to do on the calculator because it's got x in it, right? So I don't know. See if you can make some sense of it. Pause the video, see if you can even get the first step. All right, so normally what we want to do on these questions is make them into like one big root, like x over x cubed or something. But we can't do that here because we have a 4th root and an 8th root. Okay, so this thing we did earlier, not going to work here, right? So the trick is to switch the forms. So I'm going to rewrite this one, right? And sometimes, switching forms isn't the right thing, but we can at least try it and see if it helps us. So if we switch them to fraction exponents, we'd have power of 3, root of 4. This one would be power of 2, root of 8. All right, so now, now that we have the other form, basically this exponent rule is you subtract. So if we have like x to the 5th over x cubed, x to the 5th looks like that, and x cubed looks like this, and so you just cancel them out, and you end up with x squared. So the short version is just to subtract the exponent. So our answer here is going to be the base of x, and we're going to minus 3/4 minus 2/8. Okay, and in order to subtract, you need a common denominator. But luckily on this one, this 2/8 is actually the same thing as 1/4. So I can just make that into 1/4. And so we'll end up with x to the 2/4 power, 3/4 minus 1/4. And then that actually reduces a little more because 2/4 is the same thing as 1/2. So our answer here is x to the 1/2 power. And you can write it that way, or if you want to write it as square root x, power of 1, root of 2. Either one is just fine for your answer on that. Okay, and I'm just going to keep going through as many examples as I can. Yeah, because every problem's a little different, right? I guess one consistent thing is oftentimes you'll switch forms, right? So give this one a shot. And actually, the right first step on this one is to switch forms. Okay, so switching forms. This is a power of 1 and a root of 2, so it's 3 to the 1/2. And then we have 3 again with a power of 1, but a root of 4 this time. Okay, and so a lot of times people think you'll get a 9 here, but when you have the same base multiplied together, you just keep the base and add the exponents. So our answer here is going to be 3, and then we just have to add 1/2 plus 1/4. All right, so that's tricky. A lot of times students want to put a 9 there, but just keep the base. And so now we've got to add 1/2 and 1/4. So the common denominator is 4. So 1/2 is 2/4 plus 1/4 is 3/4. So we end up with an answer of 3 to the 3/4 power. All right, let's see if we can get at least one more in here. It says end of day 1, so this would be a perfect place to end. This is really hard to see, so I'll rewrite it. It's negative 32 to the 4/5 power. All right, give it a shot. All right, first thing on this is to realize you can just do it straight on your calculator, as long as you use the parentheses for the negative. So I can do parenthesis negative 32, close parenthesis, raise it to the 4/5 power, sorry. I think that's the right exponent. Yep. Then enter, I get 16. Okay, so this certainly would be equal to 16. That's probably the easiest way. But the other way is you can actually switch forms. And so if I switch forms, I have negative 32 fifth root, right? My root is 5 and my power is 4. Okay, and this actually cleans up pretty neat if you do the root first, right? 32 is a perfect fifth root, so that'll actually be negative 2. And then take that to the 4th, and that's how we get 16. So on these ones, if you do the root first and then the power, oftentimes it'll clean up nice and neat. And you'll see that as we go into some of the day 2 examples for section 6.4. So that's it. You're just cleaning up things using exponent rules. And again, oftentimes you're switching forms from the rational exponent form into the radical form or vice versa. All right, thank you for watching.